privacy. It's really important, especially if you're dealing with kids. And why don't we start off there, Diana, about what you're enabling consumer electronic companies to do with some of their products.
We are at RiseLink, and we're a semiconductor company powering edge AI applications. So I'm going to introduce some of the products that we're covering. This toy, it's actually being featured at CES. Its name is ChooChoo. It powers interactive reading for children 3 to 6 years old. Parents these days often complain that they don't have enough time with children, and privacy is a huge concern. Previously, everything is being processed in the cloud, but we are often worried about what kind of information is stored there. But now things are being moved to the edge, especially with our latest chip, BK7259. Some of the information, for example, each children's sensitive data, their voice, etc., are stored on the edge so that people don't have to worry about privacy anymore. And love to have more conversations about what should be in the cloud, what should be on the edge. But yeah, this toy is our starting point for that conversation.
Excellent. Well, that's a great start to the conversation, and it seems like the other part about this is you're reducing the power at the edge, right? So you can do this, right?
Exactly. So power at the edge is something that all the devices are worried about. When the toy is talking to your children or when you're smart lock, you don't want it to run out of power within like a very short period of time. This toy, for example, it can stay on for 8 hours, so you never have to worry about it powering off or having connectivity issues as we're interacting with it. So yeah, it's a very hard, actually, architectural question for chip design in terms of optimizing for the power and also how much efficiency it has for processing power. And this took us a long time to figure out.
And that includes the Wi-Fi as well, because you're combining both, right?
Exactly. So there's the Wi-Fi part, there is the connectivity, so the Wi-Fi part, and there's a computation, but it also powers the speaker, the mic, so it's a very integrated chip, everything in one place, so you don't have to worry about all the other aspects.
Now, are you actually running the inference on this device as well?
Yeah, exactly. A lot of the inference and algorithm is run on the edge. So I actually got my PhD at Yale studying this question, and we're incorporating a lot of the research behind ChooChoo, the toy. So for example, what is on the edge? We are recognizing children's behavior. For example, are they stuck on when they're answering certain emotional questions? Do they understand what's going on in the story? What do they usually have trouble with? The more complicated things, for example, like their language progress, they are stored in the cloud. So it's a very intricate decision in terms of to decide optimizing for power and what's being processed on the edge.
So in this example, you're actually using it as a teaching device then?
Exactly. So teachers, libraries use this toy, today actually, in San Francisco and San Mateo, for children 3 to 6 years old, because we used to always have to have parents tell stories, but they may not have enough time, or they may not be asking the right question, they may not know what exactly is going on in the stories, but research has shown that interactive reading is a very good form of helping children learn language, express emotions. So this is what we're incorporating with the power of AI and conversational AI. The super low latency combination ensures that we can actually have a very natural conversation. So the child can just talk to the toy as if it's actually a friend and have a very human conversation about it. And it can express emotions to the child too, and then also ask how the children are feeling about different things. So that we're featuring for 3 to 6 years old, so before school they can understand more about their emotions, how to interact socially as well.
And so these are very specialized AIs that are built for the devices, the mini devices you're showing here.
Exactly. So maybe I can talk a little about what are the different components that go into these smart devices, the AI native devices. So there are usually 3 parts. There's the AI backhand that determines how the device is going to interact with the children. What kind of questions is it going to ask? What is going to be safe to be interacting with children? Because we don't want inappropriate content to be broadcast. And then there's second part, there's a conversational AI part, which is that you want very low latency, and you want to know when the children is taking a pause to think versus when it is actually finished talking. So we don't want the conversation to be very non-human, non-natural. And then third part, there's the chip part, which as we talked about, low power, what's being processed on the edge versus in the cloud. So these three components make up the whole product when you have like a voice conversation device.
And I would imagine with other kinds of devices, whether it be these cameras or whatever, it's a similar type of thing.
Exactly. So the smart locks here that we're seeing, for example, it can recognize your face under 200 milliseconds. It can process voice instructions on the edge, again, and it can recognize different people in your household and their voices. And something actually I forgot to mention about the toy too is that if you have like 3 children, for example, at home, it will remember on the edge who is behaving like what, and then whose voice is like what, so it doesn't mix up, the preferences of children. And the same thing can be incorporated into other devices as well. And then a very cool application we're also seeing is in 2-wheelers. So now your bike or your e-bike can be intelligent as well. So what that means is that you can like talk to your e-bike to help you navigate to a certain place and go to your favorite club. So everything can be intelligent these days with the chips.
And from a privacy perspective, that's huge because now suddenly you can use this facial identification, not worry about going out to the cloud.
Exactly. And this is important not only for smart locks, but also for Wi-Fi cameras, where if you have a camera at home, you don't want it and any data to be in the cloud unless it's extremely necessary. So now that's possible with a chip, with a compute on the edge. So what it can do is that it can run a parameter with millions of parameters, or a model with millions of parameters, so that it can recognize, for example, did your cat leave the house without uploading any data into the cloud.
Excellent. Well, Diana, thank you very much for this explanation.
So much. Yeah, I love it. Thank you.